So have you ever thought about how crazy the range of lifespans is out there?
Yeah, it's pretty wild.
I mean, like a butterfly, they only live for what, a few weeks. But then you have like giant sequoia trees that can live for centuries.
It's incredible, isn't it?
It really is. And it kind of got me thinking even more about this whole lifespan thing. When you requested a deep dive into like what actually determines how long different creatures get to, stick around.
It's a fascinating question.
It really is. So we've got some excerpts from a book that really delves into this whole topic.
Oh, cool.
Yeah. And let me tell you, it is packed with some seriously wild examples.
I'm intrigued. So are we talking about like the differences between those short-lived butterflies and like the Methuselahs of the animal kingdom?
Exactly. We're talking trees, sharks,
What else?
oh, get this, even a jellyfish that might actually be immortal.
Hold on, an immortal jellyfish. Okay, now you have to tell me more about that.
Oh, we'll definitely get to that.
Okay, good.
But first, I got to mention this one thing about trees that the book talks about.
Right.
It's like they can practically clone themselves.
What do you mean?
Like take the Newton apple tree, for instance.
Okay.
So like cuttings from that original tree, they're still alive today. Isn't crazy?
It's like pieces of the tree are achieving a sort of immortality.
Right. It really makes you rethink the whole concept of lifespan. Like, what does it even mean?
Totally. It's like the tree lives on through its descendants, like a legacy.
Exactly. But then you have these animal outliers, like, have you ever heard of a hydra?
Yeah, I think so.
Well, according to the book, they don't even seem to age.
Really?
Yeah. Like, they just keep on going and going.
Now that is fascinating. It's almost like they've found the fountain of youth.
I know, right? It's like, defy aging. But even more mind-blowing is the immortal jellyfish.
Okay, the immortal jellyfish. We have to talk about this.
Yes. They can basically age in reverse.
What? How is that even possible?
So like when they get stressed or injured or something, they can just like revert back to an earlier stage of development.
So it's like they hit a reset button.
It's like a biological reset button.
That's incredible. It sounds like science fiction.
I know, right? It's wild. So when scientists say these creatures are biologically immortal, what does that even mean?
Well, it's not like they can't die.
Right.
Predators, disease, all the usual suspects can still get them.
Oh, of course.
But the chances of them dying just from old age, it's basically zero.
So theoretically, they could just live forever.
Pretty much. It's no wonder gerontologists are so obsessed with these creatures.
Yeah, trying to figure out their secrets to eternal youth, I guess.
I mean, wouldn't you be?
Totally.
Yeah.
But, the big question is, how do those findings apply to humans?
Yeah, good point. We're way more complex.
Right. And our aging process is way more intricate.
Plus, their regenerative abilities, they're just more plant-like. It's just not something we see in mammals.
True. Okay, so maybe immortality isn't in the cards for us. Well, not yet anyway.
But the book, it goes into mammals. And size seems to play a big role in their lifespan.
Oh, yeah, definitely. The bigger the animal, the longer they tend to live.
Right. And it's all because of their metabolism, right?
Yeah, how fast they burn energy. So larger animals, they tend to have a slower metabolic rate.
So they're more efficient.
Exactly.
But they're sipping on their energy reserves instead of guzzling them down.
I like that analogy, like the difference between, say, a gas-guzzling sports car and a fuel-efficient hybrid.
Exactly. So basically, a whale is like the Prius of the animal kingdom.
I mean, kinda, yeah.
The book mentions something called Kleiber's Law.
Ah, yes, Kleiber's Law.
It explains that whole body mass and metabolic rate connection.
Right. But what really blew my mind was this idea about a fixed number of heartbeats.
Oh, yeah. The 1.5 billion heartbeat rule.
Yeah, basically, research suggests most mammals, no matter how big or small, they all have around 1.5 billion heartbeats in their lifetime.
So, like, are you saying our lifespans are predetermined? Well, not exactly. I mean, obviously there are exceptions.
Right.
This is where the work of Jeffrey West comes in.
Oh, okay.
He's done a lot of research on this.
So what did he find?
He showed how lifespan can be predicted based on size, but there's variation. And humans were a prime example.
No way.
Well, think about it. Thanks to healthcare, lifestyle changes, we're already living longer than that 1.5 billion heartbeat benchmark suggests we should.
Shoo, that's a relief. But are we kind of messing with the natural order of things then?
It's a valid question. The book makes this distinction between life expectancy and maximum lifespan.
Right, so we've definitely increased our average life expectancy over the years.
Dramatically.
But what about maximum lifespan?
That's a different story.
Yeah.
It seems to be much more fixed, like a hard limit.
Okay, so is there a limit on how long humans can actually live? The book mentions this researcher, Stephen Ostad.
Ah, yes. He studies species that kind of beat the system.
Like they're breaking the rules of aging.
Kinda, yeah. He came up with this thing called the longevity quotient.
The LQ.
Yeah, it's a way to measure how much longer an animal lives compared to what you'd expect for its size.
Okay, I'm following.
And guess what? Humans actually have a pretty respectable LQ. It's 5.
Seriously?
Yeah.
We're doing all right for ourselves then.
It's not bad, right? But there are some real overachievers out there who make us look like amateurs.
Okay, now I have to know, who are these longevity champions?
Well, we've got bats.
Bats.
Yeah, and naked mole rats.
Wow, okay, naked mole rats. But if we have a decent LQ, why aren't we living even longer? Is aging just inevitable?
That is the big question. The book dives into this whole debate. Some scientists think aging is programmed into our genes.
Like it is in our DNA?
Exactly.
Yeah.
While others believe it's more about the damage we accumulate over time.
Wear and tear.
Yeah, like a car that eventually breaks down.
Makes sense. But those creatures that seem to have cracked the code of longevity.
Yes, those outliers.
I'm dying to hear about
Oh,
them.
we're definitely going to explore those.
Okay, good.
We'll dive into the specifics of some of these fascinating cases.
Say
Like
it.
giant tortoises, for example.
Oh, yeah, they could live for like, what, 200 years?
Some even longer. They have amazing resistance to disease, and they live life in the slow lane.
And figuring out their exact age must be a challenge.
It's not like they come with birth certificates.
Right, it must be like trying to count the rings on a giant sequoia.
Exactly. But we also can't forget about those aquatic marvels.
Oh, yeah, those creatures living in the deep. They must have some serious secrets to longevity.
Absolutely. The beluga sturgeon, for example.
Oh, wow.
And then there's the Greenland shark. Fun fact, it swims slower than your average 80-year-old human.
Seriously. That's hilarious.
I know. And then there's the bowhead whale, which actually has a surprisingly high metabolism considering how long it lives.
These creatures are full of surprises. And the book also mentions a bird, Major Mitchell's cockatoo, that lives way longer than it should for its size.
Right. It's like nature is constantly challenging our assumptions.
Totally. And speaking of challenging assumptions, those superstar bats we talked about.
Ah, yes, the bats. They're fascinating.
I bet their ability to fly and hibernate plays a part in their long lifespans.
Definitely. The Brandt's bat, for instance, has an LQ of about 10.
Wow, that's twice ours.
Yeah. And another interesting fact, male bats tend to outlive the females.
Oh, that's curious. I wonder why. Maybe the ladies are just working too hard.
Maybe.
But anyway, we can't forget about the rock stars of aging research.
You mean the naked mole rats?
Yes. They're known for being resistant to cancer, right?
They are. And they might even be defying Gompertzy's law.
Which states that the risk of death increases exponentially with age. Right.
Exactly. These little creatures are full of mystery.
It seems like every answer we find just leads to more questions.
That's the beauty of science, and that's what makes this whole deep dive so fascinating.
Absolutely. We've gone from immortal jellyfish to long-lived tortoises and everything in between.
It's quite a journey.
It really is. But what does all of this mean for us humans? Can we push the boundaries of our own lifespan?
That's the ultimate question, isn't it?
It is. Maybe we can even crack the code to living longer, healthier lives.
Now, that's a goal worth striving for.
It really is.
Yeah.
But that's a question for another time.
Absolutely. We'll dive into those questions in the next part of our deep dive. Stay tuned.
So we've explored this incredible range of lifespans in the animal kingdom, but what about us humans? I mean, it's crazy to think that just a few centuries ago, making it to your 30s was like a pretty good run.
Right. It really shows you how far we've come in terms of life expectancy.
It does. And the book talks about how public health measures have played a massive role.
Oh, absolutely. Things like sanitation, vaccines.
The things we totally take for granted today.
Exactly. And even fertilizers.
Wait, fertilizers? Really?
Yeah, it's fascinating. Fertilizers led to a huge increase in food production, which obviously had a huge impact on health and nutrition.
I never would have connected those two. It's like a chain reaction.
Yeah, right. It shows how interconnected everything is.
But this brings us to a big question. Is there a limit to how long humans can live?
Ah, yes, the age-old question.
And the book presents some different perspectives on this, right?
It does. You have someone like J.L. Shansky who believes there's a fixed limit.
Based on what?
His analysis of mortality rates. He thinks even if we got rid of all the major diseases like cancer, we'd only see a small increase in lifespan.
So he's saying we're stuck with a hard limit.
Pretty much. But then you have James Vaupel, who has a completely different view.
What does he say?
He argues that lifespan is more elastic, like it can be stretched.
Interesting. What makes him think that?
He points to species that have negligible senescence. Basically, they don't really age.
Like those tortoises we talked about, right?
Yeah.
Their risk of dying doesn't increase with age.
Exactly. So it suggests that maybe aging isn't totally inevitable.
But what about humans? I mean, the book talks about Jean Calment, who lived to be 122.
Oh yeah, Jean Calment, she's a legend.
She lived through 2 entire centuries.
It's mind-blowing, isn't it? She even met Van Gogh.
No way. That's incredible.
It really makes you wonder if some people are just genetically programmed for longevity.
I mean, it's wild to think she smoked for most of her life.
I know, right?
Goes against everything we've been told.
It does, but I guess it shows how complex this whole aging thing is.
Right. It's not just one thing. It's a combination of genes, lifestyle, environment, who knows what else.
Exactly. But even with these outliers like Calment, the question still remains. Is there a statistical limit to human lifespan?
The book mentions a study by Jan Vieg who says there is.
Right. He used demographic data and suggested a limit of around 115 years.
So he's saying the chances of someone living past 125 are super slim.
Pretty much. But then you have that other study on Italian centenarians.
Oh yeah, what did they find?
Well, they found that mortality rates actually leveled off after age 105.
Hold on, so they're saying people weren't dying at a higher rate even as they got older.
Exactly. It could suggest a potential violation of Gompertz's law.
Wait, so we're back to this idea of breaking the rules of aging.
It's a hot topic in the field. Some scientists think it's just a statistical anomaly, while others think it hints at the possibility of extending lifespan beyond what we thought was possible.
It's like a scientific mystery.
It is. And it just shows how much we still don't know.
Exactly. But even if we haven't cracked the code to immortality yet, I bet we can learn a lot from those who've already lived really long lives.
Oh, for sure. And the book introduces us to someone who's been studying these people for a long time, Thomas Pearls.
And his New England centenarian study, right?
Yes, he's uncovered some fascinating patterns in their lives and health.
Okay, spill the beans. What are the secrets of these centenarians?
Well, Pearls actually categorized them into 3 groups: survivors, delayers, and escapers.
Okay, what's the difference?
Survivors are those who faced age-related diseases earlier on but managed to overcome them. Delayers, as you might guess, put off the onset of these diseases until much later.
So it's not just about avoiding disease altogether, but also about how well you bounce back.
Exactly. And then you have the escapers, who seem to avoid major health issues altogether.
So they're like dodging billets their whole lives.
In a way, yes.
Fascinating. But does Pearls offer any practical advice on how to live to 100?
He does. He created a website based on his research called livingto100.com.
Cool. What kind of stuff does he recommend?
Well, a lot of it is what you'd expect.
Like healthy diet, exercise, stress management, all that jazz.
Exactly. But there are a few that might surprise you.
Okay, I gotta know. Hit me with the surprising stuff.
For one, he recommends tea over coffee.
Really? Why is that?
I'm not entirely sure on the specifics, but it's based on his research.
Interesting. What else?
He also suggests reducing iron intake.
Iron. Isn't that important?
It is, but too much can actually be harmful.
Who knew? Anything else?
And this one might surprise you even more. Good dental hygiene.
Wait, you're telling me flossing could be the key to a long life?
Hey, you never know. It shows that even the small things can make a difference.
True. But I'm still stuck on this whole fixed limit to lifespan thing. The book mentions a bet between Ostad and Olshansky.
Ah, yes, the longevity wager.
They're betting on whether we'll see a 150-year-old human, right?
Yep. Ostad thinks we will, while Olshansky thinks it's impossible.
That's like a scientific showdown.
It really is. And only time will tell who's right.
I guess so. We've come a long way on this journey, from those short-lived butterflies to those resilient naked mole rats.
We have.
And what I find most captivating is the mystery surrounding our own potential for longevity.
It's the ultimate question. How long can we live? And how do we live those years to the fullest?
Exactly. This whole deep dive has really been an eye-opener. We started with a simple question about lifespans, and we've ended up exploring what it means to be alive.
It's a journey of discovery.
It is. And while we may not have all the answers, it's been a rewarding one.
It reminds us that even in the face of our limitations, there's always more to learn.
Always more to explore. And maybe, just maybe, even more life to live. But before we get too philosophical, let's shift gears and delve into the science of aging itself.
Good idea. We've touched on some interesting concepts, but I think it's time to go deeper.
Agreed. Let's unpack those hallmarks of aging and see what's really going on.
Sounds like a plan.
It feels like we have explored the entire animal kingdom at this point.
We've covered some serious ground, that's for sure.
Tiny, immortal jellyfish, giant tortoises. We even talk about flossing and how it might help you live longer.
Right. It's amazing how much variety there is out there when it comes to lifespans.
It really is. But it seems like no matter how long or short a creature lives, there's this common thread.
You mean this idea of accumulated damage over time?
Exactly. And that brings us to those hallmarks of aging.
Those key processes that contribute to, well, everything wearing down.
Right, like the book says, it's not just one thing, it's this whole web of factors.
And they all work together.
So it's like one problem leads to another.
Like a dominant effect. And eventually, well,
You start feeling those aches and pains of getting older.
Exactly. But the amazing thing is that scientists are making some real progress in understanding these hallmarks.
Really? So they're figuring out what's actually happening at a molecular level.
They are. They're identifying specific genes and pathways that are involved in these processes.
That's pretty amazing. But is there any way to actually intervene, like slow down or even reverse the damage?
That's the ultimate goal, isn't it?
It is. So are we talking about actual anti-aging therapies here?
It's still early, but there's definitely a lot of promising research going on.
So it's possible that we could actually see some of these therapies become a reality in our lifetime?
I think so. Some researchers even believe we could slow down or reverse some aspects of aging within the next few decades.
Wow, that would be incredible. Imagine a world where people could not only live longer, but also stay healthier and more vibrant for much longer.
It would change everything, wouldn't it?
Totally.
Yeah.
But it also brings up a lot of ethical and societal questions.
You're right. What would it mean for our healthcare systems, for our economies, even for our relationships?
It's mind-boggling to think about.
It really is. And it's crucial to have open and honest conversations about the potential impact of extending human lifespans.
I agree. This isn't just about science. It's about society as a whole.
Exactly. But this whole deep dive has really made me think about the big picture.
Me too. We started with a simple question about lifespans.
Yeah.
And we've ended up exploring the very essence of what it means to be alive.
And to age, and to eventually face our own mortality.
Yeah. But even though we don't have all the answers, this journey has been incredibly rewarding.
It's reminded us that there's always more to learn and discover.
And maybe, just maybe, even more life to live. So to our listener, as you continue to ponder the mysteries of lifespan and the possibilities that lie ahead, we leave you with this final thought. If scientists could actually pinpoint the mechanisms that allow certain species to resist aging, could we use that knowledge to extend human lifespans? And would we even want to? What would be the ethical and societal implications?